So for this day, notice there were kind of two goals. When you have parallel lines, there's lots of angle relationships that we're going to be aware of. Now, if the lines are not parallel, these relationships do not exist. But for parallel lines, there are certain things that are definitely going to be true. So I gave the kids this picture, this piece of paper, and then they got cut out of all these different angles that might be formed when you have parallel lines and a transversal. And the thing about these pictures is, for all the angles that are marked in each individual diagram, those angles are either going to be equivalent to each other or congruent, or they're going to add up to make 180 degrees, which means they're supplementary. So part of this is just to have you guys build some intuition, some mathematical intuition, and like kind of use how it looks to decide, oh, these look like they would definitely be congruent, or there's no way these would be congruent, therefore they must be supplementary. And I asked the students to take a moment to like take each of these different pictures and put them in a column of either congruent or supplementary. So that's the angle relationship. The angles are either congruent or supplementary. And to give you an idea of exactly what I mean, if I look at this over here, these two guys right here, the ones that are marked in gray, they look like they're about the same size. In fact, if I were to take this intersection and slide it on top of this intersection, they'd be in the corresponding exact same places, so they'll be congruent. On the other hand, these angles here that are marked, well, this one looks smaller and this one looks larger, so I don't think that those are going to typically be congruent. I mean, I guess they could be, but in this case, they're definitely not. So they would be considered supplementary. They'd have to be 180. Again, only if the lines are actually parallel. So that wasn't too bad. Kids were able to kind of match those over here pretty quickly and easily. You should try it yourself. And then there's all these words that go with those angles. So, for example, like this one here has a specific name. And that name is somewhere on this page. And I have to connect the name with the picture. Right? And you'll see, like, it's a lot of words. Alternate interior, same side exterior, corresponding, linear pairs. There's lots of different words that we need to be aware of. But in some ways, it's kind of like the word alternate comes up a couple different times. There's like interior versus exterior. Comes up a couple times. Same side comes up a couple times. And then there's these three oddballs of like linear pair, vertical angles, and corresponding. So let's just talk about how these words hopefully make sense so that we can have them at the ready. So like, for example, if I was going to name this first one that I mentioned, I kind of gave it away when I was describing it. I was saying to myself, hey, if you were to like take this little intersection here and slide it over here, this angle ends up in the exact same place as that one. It's almost like if it were a map, I was looking at a map and this were my map down here, this is where I would like go to be in the same place. It's a corresponding angle. So these are corresponding angles. That's what it looks like. There's lots of ways to have corresponding angles, so just to give you like another heads up. Oh my goodness, excuse me. I'm going to delete some things off this page, I think. Delete. If I had another set of parallel lines and a transversal, this angle here, if I were to slide it up here, would correspond to this angle here. So those would be considered corresponding angles. If I were talking about the angle down here, if this were like a little map and I slid it up over here, this angle would land here. Those are corresponding angles. And what I hope is also evident or clear is that corresponding angles, when these lines are in fact parallel, will be congruent. I want you to know this is what corresponding angles look like. I want you to know they're congruent. Let's try and break down one of the other words. I don't want to do all 7 of these. It's pretty boring, so I'll do 2 more and just be kind of boring, I guess. Whoops, I need that tab. Loading. Alright. So, hello. I gotta use the screen snipper tool. Ga-ding. That's not how that's supposed to look. What in the heck? That's weird. Don't know what's going on there. Alright, so let's break down this one for a sec. Oh my goodness. Hello? Copy, paste. Okay, it's not. Oh, I know why. Mr. Dip Dip. Alright, so I'm trying to figure out an appropriate academic vocabulary word for the relationship that those angles are displaying, right? So this is my little word bank. But the words are from, you know, other experiences in life, hopefully. Goodness, excuse me. So here's what I want to mention about this. We have two lines. And these two lines, if you think about them as like two roads that are going off in infinite directions, and you think about interior versus exterior, you might think to yourself, gosh, if I were a little dog running alongside these roads and I was in here, I'd be like on the interior of those two roads. If you're between them, that's the interior. Not so great. But if I was on this side of that pink line or on this side of that pink line, I'd be considered to be on the exterior, the outside. So, you know, as I look at these different words and I see that this angle's here and this angle's here, it looks like the angles are both in what would be considered an exterior portion of the picture. The other thing I would notice is that these angles are formed by this line, right? Like this angle, this line's part of this angle, this line's part of this angle. So that transversal runs through it, and these angles are they're not on the same side of that transversal, right? Like, if I wanted to go meet my friend over here, I'd have to definitely cross over this road. So if it's not same side, they must be on alternate sides. So if I had to describe the relationship between these two angles, I would say that these are alternate because they're on different sides of the transversal. Exterior, because they're like outside of the region that these two parallel lines create. These are alternate exterior angles. And if you also had to make a decision about whether or not these appear to be congruent, meaning equal, or supplementary, adding to 180, hopefully you'd agree that they appear to be congruent. But they're not the only alternate exterior angles on the picture. There's one other pair. Can you see in this picture what the other pair of alternate exterior angles is? Hopefully you're thinking like, oh, this angle over here is also like in that exterior region that Mr. Depsic had recently highlighted with orange marker. This is also orange. And if I go alternate, then on the other side of the transversal is this blue angle. And again, hopefully these blue angles appear to be congruent. Alternate exterior angles are congruent if the lines are parallel. That's the idea. Now with that in mind, you could probably also pick out what would change if I change this word exterior to the word interior. So we'll still be on opposite sides of the transversal, but we won't be in the area that I had marked orange. That's the exterior. We'd be on the interior, which would be between them. So alternate interior angles would have like a similar flavor, I guess, but like this would be on the inside, and this is the alternate interior, like these angles are alternate interior angles. So what have we covered, right? We've got the idea of like, if two lines are like this, and I have a transversal, and I have an angle here, and I have an angle here, this little map, if I move it up, puts that in the same place, those are corresponding, right? These are also corresponding. This, which angle corresponds with this one? Slide it down, these are corresponding. If I have an angle here, and I have an angle here, those are on the outside, they're both on the outside, they're both on the exterior, they're on alternate sides of the transversal, those are alternate exterior angles. Okay. So now, what about this other? So I've kind of covered corresponding with you, alternate exterior, alternate interior is all good to go. You might be able to guess what these do. Get this picture out of here. Beat it, picture. No one likes your style. Let's draw. Ding, ding, ding. Delete. So, same side, interior. Well, interior. Let's start with that word. Interior is between the lines. Same side. So, obviously, if we're talking about, like, before we're talking about alternate interior, this is same side interior. So we still want to be on the inside, but instead of thinking about alternate sides, I want another angle that's inside, but not on the other side of the transversal. So interior, same side would mean this guy and this guy. These guys are considered interior because they're between the lines and they're on the same side of the transversal. What's the relationship there? What do you think is true about these angles that are interior, same side? Do they look like they're going to be the same measure? Or are they going to add up to 180? If they don't look like they're the same measure, one's obtuse, one's acute. They can't be congruent. So they must be supplementary. Right? They're on the inside, and on the same side, that's interior, same side. Exterior, same side, probably not going to blow your mind, right? That's on the outside, that's on the outside. Those are exterior, same side. They're also supplementary. So, I hope that makes sense. I do need to talk about these words as well. They actually are part of the other section. We don't need parallel lines or 3 lines to talk about linear pairs or vertical angles. So I'll just kind of mention this one. And I think vertical angles is about the worst. I mean, I can think of worse names, but it doesn't really make as much sense as the others to me. Anytime you have an X going on, then the angles that are directly across from each other like this are considered vertical angles. So in the picture that I had a moment ago, there were quite a few vertical angles. This one and this one are called vertical. This one and this one are vertical, right? Anything in the X that's directly across would be considered vertical, and vertical angles are always going to have the same measure. They're going to always be congruent to each other. Look for the X. I wish they called them X angles, but I wasn't around when they named these, so I don't get a vote. And then linear pair, I kind of said that in the other notes, it's like if you have a straight line, whoa, that's not a straight line, bro. Straight line. And then another ray flying off that line, you have an angle here and an angle here. And those two angles together, let me highlight these bad boys. So this green angle, and this orange angle together form this straight line. So they're considered a linear pair, and they sum to make 180. So I don't know if you really made it all the way to the end of this 13-minute video, but having done that, you should be able to look at these notes and like put these in their correct place on this T-chart. So draw a T-chart. One side says congruent, one side says supplementary. Draw in these pictures with these markings if you think, that the angles have the same measure, put them on the congruent side. If you think that they add up to 180, put them on the supplementary side. And then do your best to use this word bank to label those pictures correctly before you look at the key. And in your head, it's kind of like we have like some opposing ideas. Like it's either corresponding, vertical angle, linear pair. They're kind of their own thing. And then for the other 4, it's either going to be alternate, meaning different sides of the transversal, or same side, meaning same side of the transversal. Or they're going to be both on the, like between the parallel lines, meaning interior, or both not between the 2 lines, which means exterior. And just think about it before you look at that key, and then try to do some of the examples. In the examples, we're either setting things equal to each other, or we're adding things up to make them equal 180. Sometimes we throw a triangle in there, and then you also have to use the idea that the angles inside of a triangle add up to make 180. So it can get to be pretty. You have to learn you have to learn how to look at specific parts and ignore specific parts, and just kind of be patient and get through it. So I hope this helps. I really do. Good luck.